Hello everyone, welcome back to another video. This video is all about an air traffic controller that I built with multiple coding languages. I struggled very much with this project. To be honest, I almost gave up. It was giving me so many issues. But before I show the project, I just want to show, so here I am in VS Code. And you can see there's quite a bit going on here. You can see right at the top, right here, you've got Python, you've got C and C++, JavaScript, and Rust. So what I'm going to do is I'm going to talk about it very briefly, and then I will show the project. All right, so before I show the project, I want to talk about it just a little bit. So this is an air traffic controller simulator. And as mentioned before, it's built with a handful of different coding languages. I used JavaScript, Python, C++. There's a little bit of C in there and Rust. So JavaScript. JavaScript is running entirely in the browser and controls everything you see and interact with. When you look at the radar screen, for example, JavaScript is drawing every single frame using the HTML5 Canvas API. The green sweep line rotating around that you are about to see, the aircraft triangles moving across the screen, the range rings, and the compass headings. JavaScript is doing all that. When you click on an aircraft, JavaScript detects that click, highlights the aircraft in white, and updates the command panel at the bottom. When you click the heading button and type in, say, 270 degrees or whatever, JavaScript captures that input, validates it, and then it's going to send it to the server. It's also playing those radar beep sounds you're about to hear as well. Okay, Python. Python runs on the backend server and is the simulation engine. Every 100 milliseconds, that's 10 times per second, Python updates every aircraft's position. So it takes each aircraft's current heading, speed, and altitude and calculates where should this aircraft be 0.1 seconds from now. So for example, if an aircraft is flying at heading 090 due east at 250 knots, right? Python calculates how many nautical miles it travels in 0.1 seconds and updates its X and Y coordinates. When you tell an aircraft to turn to heading 270, Python doesn't just snap it there. It smoothly turns the aircraft at 3 degrees per second until it reaches the target heading, just like a real aircraft would. Let's talk a little bit about C++. Where is that? What is that doing in this project? This is where the calculations come in. And here's a concrete example for you. The dotted lines that you're about to see that extend from each individual aircraft showing where they'll be in 5 minutes, that's C++ at work. You'll see this here shortly. To draw that line, we need to predict if this aircraft maintains this current heading and speed, where will it be 300 seconds from now? That requires trigonometric calculations, sine and cosine functions, distance calculations, wind effect corrections. C++ can perform these calculations in like 2 to 3 times faster than JavaScript. Another example I have is, so when checking if two aircraft will collide in the future, C++ runs a simulation stepping forward in time, calculating positions every second for the next 5 minutes, checking distances at each step. That's hundreds of mathematical operations per aircraft pair, and C++ cranks through them instantly. So we compile C++ to WebAssembly using a tool called Emscription, which converts the C++ code into a .wasm or WebAssembly file that runs in the browser at near native speeds. All right, last but not least, definitely not least, let me talk about Rust. Good old Rust, my favorite. So Rust is performing all the safety critical checks. I was hesitant to include Rust with this, and this is where I had most of my problems. No wonder I was hesitant. So, so Rust. So when checking if two aircraft are too close, for example, we are doing critical safety calculations. If there's a bug, a memory error, a null pointer, undefined behavior, aircraft could collide without triggering an alert. And that's no good. Rust prevents this at the compiler level before the code even runs, right? So Rust compiler mathematically proves that our separation checks cannot have memory errors. When Rust calculates the distance between two aircraft and checks if it's less than 3 nautical miles, I'm guaranteed that calculation will execute correctly or the code won't compile at all. So, for example, when Rust checks separation, it takes aircraft positions, calculates horizontal distance using the Pythagorean theorem, square root of x squared plus y squared, checks vertical distance, absolute difference in altitude, and then it determines if both are within violation limits. I'm going to try and break it too. Well, I'll show you. If they are in violation limits, then it flags a conflict. So this code is safety critical and Rust ensures it's basically bulletproof. So, and here I've got some No Man's Sky going, but not for long. And here it is. This is the air traffic controller. Here's what the radar looks like. Down here at the bottom, or I guess you could say the footer of the actual radar, I currently don't have anything selected, but I'll get into that in a minute. You have heading, altitude, speed, approach, and cleared to land over here. You've got your statistics, you've got your weather up here. I like that little effect. Alerts, this is what I want to try to get. And then down here in the scenario box, if I click here, I can go basic, moderate, busy, complex, or emergency. Let's just start with basic. Now I'm going to start scenario. Okay, so I've got 3 aircraft, and here's those dotted lines I was telling you about. So what I can do is I can click on an aircraft, or I could just click over here. Now, this footer piece in the radar, yeah, it's covering some of the radar, the actual radar, and I made some adjustments. I actually had all of this over here. Really didn't like the way that looked. And I don't want to put it down here because this is my command history location. So it is what it is, whatever. I'm going to actually, let's click this aircraft, and I'm going to change the speed to 400 knots, confirm. I don't know how well you're going to be able to see it, but this number just right above the crosshair, it's moving, it's increasing, and it will stop. There, it stopped at 400. I'm going to change the heading. We'll do 120. Okay, so now this aircraft right now is starting to move. Now what I'm going to do is I'm going to hit reset. Are you sure you want to reset the simulation? Yes. Okay, so everything's just going to go away. It's going to fade away. Let's do emergency, start scenario. Oh, I'm so glad I'm not an actual ATC employee. I would be not in good shape. Okay, I'm going to change so you can see the runway. I messed around with this for quite a while. It's difficult, and I'm glad that it's difficult. I was only able to land 1 plane. You can see over here in the statistics. Yeah, I had 1 landing. That was it. So let's play around a little bit here. Let's do 500 knots. Okay, so it's going up. You can barely see it, hardly see it, but it is going up. I'm going to change the altitude of this plane. I'm going to bring it down to 100. Oh, you know what? I'm also going to speed it up too to 500. I'm going to change the heading of this airplane to 180. It's moving. I'm going to change this one to 70. Change this heading also to 30. All right, so I've got some airplanes moving now. Okay, so I've got a little bit of activity. I think I may have needed to move this one just slightly more. That's going to be too much. That's okay. I'm going to speed this one up. Oh, wait a second. I can come over here and see. So this is going to show all the aircraft and it's going to show the speed. Oh, this one's going at 500 knots. And it also shows the type of aircraft as well. This is a 737. I've got an A320. Lots of well, not lots. Yeah, because then here's an A380. Here's a 777, an E175. So I can just click on them that way. See how it changed? Let's do. Let's move this one back down. And then this one's speed is at 500. I'm actually going to change the altitude of this plane to 100. I want to mess around with it just a little bit more and try and get an alert. But that's what this is. I really wanted to challenge myself and try and build an ATC project that had very basic effects. You can see the CSS used. This is really nice. I think that turned out decent. Basic effects down here, a little bit over here, and then of course these are jumping. The online is glowing. Let's take multiple languages and make what you see here and interact with it. Is it necessary to do it like that? 100% not. All the more reason I wanted to do it, but it was, I almost threw in the towel with this one. It was hard. Ooh, stop there. Let's take this one and where is this one at? Oh, that's the E1. Okay, so that's the E175 is going at 314. Let's take that altitude. Can I go that low in feet? Oh wow. Yeah, I don't know if you can see it, but it's getting really low. Let me speed it up to 500. There we go. And then this plane right here, let's take this down to 10 feet and let's also speed it up to 500. I was playing around with this for, it had to have been well over an hour, and I was only able to land one plane successfully. It's interesting. It's pretty cool. That is it. That is my air traffic controller made with multiple languages. All right, everyone. Well, I appreciate you stopping by. It was a lot of fun. I'm working on another project. I'm still trying to get this Pac-Man game done. It's not necessarily that it's difficult. It's just I get back to it, I start working on it, and then I come up with another idea for a project. No, buffering issue there. So this next project that I'm working on is a video game organizer. I'm super stoked about it, but until then, I will see you in the next one. Take care.